cloud. Perfect. Okay. So we're going to continue our discussion on methods, classes, and packages. We were really, I think, last time talking about methods, method headers, method bodies, but then looking at API documentation, which gives you viable and important and valuable information about methods that other people have written that you can then import and use in your own software. And so if you want to use the methods that other people have authored, it's important to understand how to parse that documentation. I think we started to do that, if I'm not mistaken. Now, I don't have those tabs open, and let's go to where we last left off. So we had mentioned the overview. We had mentioned methods here. I think we got, is this about where we were at? I think about right here, the methods break was here. Was it at the API breakdown? Let's see. So I know we talked about this. We talked about the methods breakdown, about how a method can be divided into a method header and a method body. And the method header gives to the JVM all the important information that that method does before you even start implementing it. So it lets the JVM know, hey, what has access to this method? So if it's public, everything has access to it. If it's private, only this particular class. So anything outside this class is restricted from it. If it's a class, if it also has class in the access level, then it means the method is available from the class name itself. We're going to see that in the example that I'm going to go ahead and illustrate to you when we start building out when we use the math class, and then we build out our own method that we'll call maxgetter. Then we have the return type. The return type is either a void or a data type. It's void if the method is a procedure type method where all it does is process a set of statements, but does not return back a value. It has a non-void return type, which could be an int, it could be a double, it could be a string, it could be a Boolean. If it is a method function, which means it processes, it executes a collection of statements, and then afterwards returns back a value of that data type. So one thing you should always recall with a method function is that it has to have a return statement. Remember, we did a sample method last class where we gave a return type for a method procedure, one that doesn't give back any data, one that had a void return type, but that is optional. We saw that that method also works if we omit the return keyword, but it does not work on the flip side of that if it's a method function. And then we have the name of our method, which does not have to be unique, unlike variables. And that's because the signature of a method, the signature in our programming languages are the things that have to be unique. The way that the JVM identifies between methods is based off of a combination of the method name and the set of inputs that the method uses. So that would be the parentheses with all of the local variables that are declared as input values. And so again, just like any other kind of variable declaration, it's going to be defined by data type, and then whatever name we want to apply to that variable, it should be meaningful. And then we can use that variable inside of our method to represent whatever inputs the end user or whatever the client code, we usually call that client code, whatever the client code is providing to this method. Okay, so here we go. We were at the list of modifier and type method plus description. So I think that's probably where we're at, huh? Okay, and then we did this. I know for a fact we did the sample code. So I'm not going to walk deeply into this because if you need a recount of this, you'll get it in the video when I post it later today. So I will skip this slide, but this is the one that I was talking about earlier, where we had the two return statements. And then I do remember omitting this one to illustrate that it still works, but you can't omit this one because this one says it does return back a string. And then we also looked at the inputs here, where we give those inputs and they have to be in order for it to work, because I showed those error messages as well. Then we talked about the API, and we highlighted the fact that in our Java code bases, the way that it works is we have our instructions that actually do operations. All of our statements go into methods, all of our methods go into classes, and then all of our classes go into packages. And so the API documentation will show you what are all the packages. Well, packages can be nested inside of packages as well. So what are all the packages and classes inside of a given package? What methods are inside of a class? Because the smallest unit of code inside of Java is a method. In fact, if you ever hear of unit testing, or which is something you'll learn about next semester in Java 2, the unit you're testing is methods. You're testing on a per unit basis. And I believe we even opened up an example. Didn't we navigate last class to Oracle's API and look at something like this, where we did a breakdown of this is the modifier and type. So the API documentation is certainly in line with the same way we declare those headers inside of our code base. So this is the access level. And again, we omit public because if you're going to be on the API, you're available to other developers. We ignore all the private methods because they're not important to us as external developers, as client developers. Static lets us know from where we can call this method from. So we know that if it's a static method, we can call it from the class itself. We're going to see an example of that to really internalize what that means. Here, double is the return type. So this, I know just by reading that I'm going to get back a double when I call this method. And then the method signature is given to me. So that's going to be the name, which is in the bold. And then the set of inputs are in between the parentheses. And again, the set of inputs are always going to give the data type and then a labeling. So in this instance, the one that's called abs for absolute value is going to give the label of A. So that's just a variable name to the input that goes into there. And then we would have this description. This returns the absolute value of a double value. Okay, and then the next thing I wanted to do was actually start walking through the package of Java.lang. And I think we started that. And in fact, and I think we even got to the math class. Let me get to that. So let me pick back up from there. So math, Java 18 API. So I'm just going to Google search with some keywords that I know is going to bring me to where I need to go into the API documentation. Here, one rule of thumb is always use the most up-to-date version of software when it's available. And that's true for any software, right? So if your operating system has an update, you should install the update. If Java has an update, you should install that update. So I'm not going to look at Java 8. I'm not going to look at Java 12 or 13. I personally run Java 18. Now, there is a caveat to this. Usually what most enterprise firms are going to do, or larger companies are going to use what's called the LTS release. Is everyone familiar with what an LTS release is? So usually there's two versions, especially in the developer community, where you have the newest version and then the LTS release. The LTS is long-term support. So if you commit to implementing on a code base and you know that that code base has to be supported for a number of years, then you want to adhere to a long term of support release so that you know that 3 years from now, 5 years from now, they're still issuing that's still going to be a supported API. Now, they'll have releases before then, and if you're developing software for fun or for your own personal projects, it's always nice to get the newest version to see what they've added to it. But in the professional realm, usually you restrict yourself to LTS releases. So I'm just letting you know, I'm saying always install the most up-to-date version, but I live in academia and I don't, build professional software that has to meet production level requirements all the time. So those developers would say always install the LTS version, but the most recent LTS version. Okay, let's see here. Let's go to our Java 18 specification. So here, there's a couple of things we're going to see. I think I highlighted this last time. We have the module. The module is a nested package that's inside of Java.lang. So Java.lang is implicitly imported into all Java applications. So that means every Java application gets everything inside this package. We don't have to import it like we have to do with Java.util. So inside of Java.lang, I'm just going to pick and choose some interesting things, such as the math class, because I actually want to show you samples of the math class. Remember, the motivating thing I said last time was that one of the issues with the arithmetic operators, the primitive arithmetic operators that we have access to, is that they limit you to very remedial computations, right? Like you can do subtraction, addition, multiplication, and division. That's it. So very often is the time that you need more complex math operations, and you probably don't want to have to code those yourself by scratch. So what Java has done was include as part of the standard libraries, part of Java.lang, part of the language spec, is a class. And remember, one of the things that classes provide to us is it allows us to group a collection of related methods together. So we know a method is a block of code. It's a code block that performs some task. And the task that it performs is usually told to us in its name. So if we have a group of similar tasks or related tasks, like taking the absolute value, computing the, let's say, the trigonometric functions, finding the square root, taking the power, these are all mathematical operations. So it would make sense that we would cluster these, we would group these all together into a class that's called the math class. So let's go into the math class here in the API. Here we have our fields. Fields is just another name for a variable. These aren't really variables though, because they use the keyword final. Final means that it's read only, or another word for that is constant. So these are constant values that are static, so they're properties of the class, and they give us our value of e, and they give us our value of pi, and then we have all these methods. And so this is one thing I want to highlight. Look at the first, what is the interesting thing about the first four methods that are defined inside of our API here under the math class? Yeah, and so that's the idea. You can have methods that all have the same name. In fact, this is a strategy that the architects of Java wanted to really promote. It actually has a name. This is what's called method overloading. Method overloading means you can have methods that have the same name, but the JVM can differentiate one from the other because it doesn't use just the name to select what method, what block of code is going to get executed when you use it. It's also going to look at the set of inputs to make that decision. So notice, even though the first four methods all share the name abs, short for absolute value or absolute, they all have a different input. Now, the number of inputs is the same. It's one input, but the data type is different. So what does this mean to us transparently? It means that it doesn't matter what data type our numerical value is, whether it's a double data type, or whether it's a float data type, or whether it's an int data type, or a long data type. Notice those are all numerical data types, right? But they're technically different from one another because they're either fractional, or they are integers, right? They're non-fractional, or because they have a different amount of encoding space. So they can be larger than other numbers, right? Like longs can be a bigger number than what int supports, or double can have more precision points than what float has. But regardless of what you use for your number, by overloading the method abs, it doesn't matter what the data type is, you can still use the same method name. You see how easy that is? Think about if you couldn't do that. What would be the alternative? You'd have 4 methods with 4 different names. One would be abs double, abs float, abs long, and abs int. Right? It'd be like using the scanner object where you have to specify the type of data that you're putting into the method in order to try to get back. But with method overloading, you make that transparent. You only have to remember one method name, and then it selects based off of the data type you use. You see how much easier it is for you that you have to remember less because of that? So, I mean, does that make sense? Does everyone understand the value of method overloading? Excellent. Okay, so with that said, just looking at this, we have this. So obviously, if we send in a double, we're going to return back a double. If we send in a float, we're going to return back a float. If we send in an int, we're going to return back an int. And this just gives us a description. So returns the absolute value of double, returns the absolute value of float, int, long. So let's see some of the interesting methods that we have here inside of the math class. So we also have like the arc cosine, we have arc sine, arc tangent. So if you have to do any interesting either trig functions or geometry functions, you can go ahead and process your results there. We have ceiling. What do you think ceiling does? Taking the ceiling of a number. Yeah, exactly. So it's going to return the smallest double value that is greater than or equal to the argument. And then same thing with floor, where it will remove the fractional component, right? So the ceiling, so like if I did ceiling of, say, for instance, 4.7, it'll just bring it to the next highest integer. If I did floor of 4.7, just brings to the next lowest integer, right? Rounding is the thing that makes the decision on whether it is 5 or higher, then it gets rounded up, or if it's 4 or lower, it gets rounded down, right? That's rounding. Floor and ceiling doesn't care. If there is a fractional number and it's a ceiling operation, it just elevates it up to the next level. If it is a floor method and it has any fractional number, then we'll just bring it down to the next lower value, just drops the fractional component. Okay, let's see what else we got here. Yep, that's floor. We have log values, we have max values, min values. Here you can take in 2 different numbers and it'll return the max value, 2 different numbers and the min value. You can see there is a lot of methods in here. Here's one that you used. We'll use it again today because I want to have a, I'll probably give a lecture on this on Tuesday. Well, yeah, this is actually what I'll do on the pre-recorded lecture. So this will be a fun lecture to listen to. So we'll talk about random numbers. And you've actually seen this method already because that was in the homework, right? The way that we got the zombie to move around randomly was we used the math class, and inside the math class is a random method, and the random method returns back a fractional number that is scoped between 0 inclusive and 1 exclusive, which means that it can never be the number 1. It's going to be some number that always is the number 0 point, and then anything from 0.0 to 0.99999 until there's no more memory to have nines. So we'll take a look at that in a moment. And we have square root here. So that if we need to take a square root, that's pretty valuable if you ever need to compute things like error or distance or things like that. And we also have, where did Powell go? I guess it would be here. And here, if we wanted to go ahead and compute the power of something, the base would be here, and then this would be the exponent value. So if you wanted to do like 2 to the power of 4, I could put 2 as my A and 4 as my B value. Excellent. Does anyone have any questions in terms of reading the API? Is everyone comfortable looking at the API and kind of understanding what these methods do? Okay, so everyone can read the descriptions. Does everyone feel comfortable reading the inputs values? Okay, and does everyone feel comfortable being able to see what output it's going to get back? So let's play around with some of these then. And before we play around, I just want to highlight we are going to play. I just want to illustrate that here. There's other things you should be aware of, like, string is part of Java the Java.lang package. If you ever want to see what things you can do with strings or integers or doubles, like they have all these built-in methods that you slowly learn sometimes by working through the lab, right? Sometimes your lab instructor will show you these methods you didn't know existed. But if you wanted to learn where they existed without having to depend on like the lab instructor or myself showing you, this is where you would go to find these things yourself, right? So in absence of someone else explicitly saying, hey, you could do this cool method, you could explore, you could browse what's available to you through the documentation. So all of the data types, all the primitive data types, I would recommend you just perusing the methods to see what's available to you. So I know that we've used the system.format. I'm pretty sure we use it. I'm sorry, string.format, which is a really powerful mechanism for us to make formatted strings without having to send it into the output stream. Okay, let me go back now to our slides. So here's some examples of some calls, and I want to go ahead and we'll walk through this. But the first thing I'm going to do is make a class math methods.java. Okay, so now I have this. Let's go ahead and open that up. So we'll open that up in what do I usually use? Visual Studio Code. Okay, well, despite what I just said, we will ignore the update in the middle of a lecture. Don't always install the newest version right away. Okay, so here we have math methods. Let me cut code out and I'll add it in as it's relevant. So let's cut out and always say, because I like the evolution of code. I think there's something to be said with how things evolve over time. So the first thing we're going to do is what we always do. Whenever we create a new Java file, we determine what the class name is going to be, and that's the name we give the file name. So immediately, since I call this mathematics.java, I know I'm going to create a public class math methods. Now, inside of here, this is going to be an application. So we need to have a main method. And so the purpose of this application is to show you how we can use the math class to do more complex math operations. So it's just a demo application. So anyway, I have my main method. My main method's defined inside of my class. Let's check out some more stuff. Okay, let's cut out this stuff here. So the first thing I'm going to do is I'm going to declare some data that we're going to mutate over the course of this application. So I'm just going to make everything double so that I can have fractional values on it. So as I do my computations here, I'm just going to have an X, a Y, and Z value that are random values. One's X is 100.6, Y is 3, Z is minus 345. So again, these don't model anything. This is just to show you math operations. So they're allowed to be random numbers. They're allowed to be bad variable names like X, Y, and Z, because that's really representative of what mathematicians do, right? Mathematicians are horrible at naming variables inside of their algorithms or their formula. I mean, they don't even update the names after when they're given. You give a name to a formula back when it was developed in the language of Greek, and we still use pi and theta and mu, and it'd be so much easier if we updated some of the terminology there, make it a little bit more transparent in terms of learning what those formulas are really expressing. Okay, let's see here. Let's take a look. So what I'm going to do here is I'm going to invoke those math methods. Now, like I said, since the math class is part of the Java.lang package, I don't have to import it. So I can use it right away. And because those methods are static, I have access to them from the class itself. What that means is we can use a dot operator. Remember, the dot operator allows us to access one thing from within another thing. So these methods exist inside of the math class. So what I can do is I can say, hey, this abs method, right, that was in the API, which was defined inside the math class, since it's a static class, I can use the class name math, and that's how I invoke it. So from class math is in abs methods. That abs method, if you remember, can take in a numerical value, any numerical value, because it was overloaded. It could be an int, it could be a double, it could be a float, it could be a long. Here we have a double, so that's the one it's going to use. It selects to use the one that matches the data type, and that's transparent to us. The JVM does that automatically. Again, one of the advantages of method overload. So remember, this has a return type. So it's going to process whatever it does internally to produce an absolute value, and then it gives it back to us inside of our code base. And since it gives us back a value, since it resolves back a value, I can then take that value on the right-hand side of an assignment operator. Recall an equal, a single equal sign is an assignment operator in Java and most other programming languages. And then I can store that into my variable result, which I had declared, but did not initialize. So this is the first time I'm giving it a value. So after I do that, I can then go ahead and print it out. I can print out, hey, the absolute value of my fractional number is going to be whatever's inside results. And then we can do the same thing if we want to do another computation. Let's say I want to find the square root of 9. Well, the math class had a method for that. We saw it in the API documentation. So let's call it. Let's, from the math class, we'll use the dot operator to access a method within it. We'll call the square root method. Oh, let's not do that. That's not the method name. Okay, and then we'll pass it a value because it requires input. And then we'll get back the result. And then we'll print that out. Then we'll test out the power method from math. So we'll supply as the first argument the base, and as a second argument, the exponent. So this is the equivalent of saying 2 to the power of 3. And then we're going to print that out. And then we're going to check out, hey, what about the max method, where I can pass in 2 values, an x and a y, and it will give me back the highest of the 2. And why don't we walk through, why don't we first collectively decide what these values should be, and then let's see if it actually rings true. So what's going to be the absolute value of z here? What is my value of z when I run this? Yeah, so that's going to be 345 is what I should get back, positive 345. What about here? What should be the result of line 11? That should be 3. What should be the result of line 14? 8, right? 2 to the power of 3 is 8. And then what about here? Math.max. Yeah, so my x is 100.6 and my y is 3. If it returns back the max, it's going to be the 100.6. And then finally, I just want to highlight, it's not just methods we can access. Remember, there were 2 fields also declared inside of the math class. It was pi and e. And since they are public, we can access them. And since they're static, we can access them from the class itself. So from the math class, I can use the dot operator and get a value of pi. So let's go ahead and run this. So the first thing I'm going to do is compile. And then here, I'm going to go ahead and run. And so here, the absolute value is 345. The square root is 3. 2 to the power of 3 is 8. And the max value is 100.6. And then pi is 3.141593. Excellent. Does anyone have any questions? And so you see how easy it is to use these methods other people have written. And the advantage here is we don't care how they work. We just care about what we need to give to it and what it gives back. Yes, actually. So suppose, that's a good question. Suppose I wanted to have only 2 decimal points. One of the powerful mechanisms of printf, which is why I like to use it so much, is that I can specify instructions on how to display that variable in between the percent sign and the f. So if I put like 0.2, that lets me know, limit the precision points of my decimal to 2 floating points. So let's actually do that on all of them. and recompile and test that out. And actually, we'll even do it here. So let's recompile. And so now when I run my code, notice everything now on my output, I can blow that up a little if you need to. Is that better? Is now and if I wanted it to be 0 floating points, I can make it 0 even. This will have the really strange result of displaying in, oh, that's not what I wanted. This will have the really strange result of printing out pi as 3. Good question though, and there's other things you can do like that as well. And if you look it up, you could see all the different options you can do with format specifiers like that, with being able, because you could front load the number so that you can prepend a 0. So it has to be like the leading digit. Let me see here. If I can, sometimes these are things that you do so little, you have to look it up every time. But let me see if it's like that. I want to say it's the value you want to prepend, you put, and then the number of units after that. So I think 04.0 makes it a 4-digit leading value, and then the precision points will be 0. Actually, let's make the precision points 2. Let's see if I remember that correctly. This is where you start getting into more eclectic things. Nope. So let's see here. I wonder if that's going to, let's comment out. Let's see if, I wonder if it's the reverse then. Well, I don't want to go down a rabbit hole because I might do that. But I'm going to do it anyway. Oops, nope, yeah, that's definitely not it. Because now, yeah, so this first one's going to limit the number of digits that it can be, but I think that is a limiting value and not a front load. I don't remember how to get the front loaded number, but you can look it up. You can definitely look it up. Is there any other questions about this? Okay, so now what I want to show you next is that even though this is given to us, there's not really any magic that's happening. It's just a convenience factor. Someone else can write a collection of methods, put it in a class, and then share it with everyone else. And now no one else has to write or duplicate that code. Notice this adheres to dry design for everybody, for sharing code. So if I write a method, I can share it with everyone else. You can import my class into your code base, and then everyone else can use my methods. So if we wanted to do a demo of that, suppose that we create our own method max. We're going to create a class that's not the math class. It's going to be the maxgetter class. And in fact, let's take a look. I think I have it inside of my slides here. Okay, so before we get there, let me make sure I've highlighted and said everything I want to do about the math class. So math is all static methods. One thing you should know about static methods, because I don't think I had mentioned this before, and I do want to make sure that it's highlighted before I move into designing our own classes, is that usually when you have a class that has nothing but static methods, and if you look at the math class, that's like the math class, right? It's nothing but a collection of static methods, which are methods that are available from the class. Usually, those are very specific classes. They're usually called utility classes. And it's because they have a group of essentially functions. It's a group of things that you use to process data with. So it has some utility to other applications. You don't build instances of it. Like for instance, the scanner object, we actually build an instance of and use. The math class, the only reason why the math class exists is to have all these utility methods. And so usually a utility class is one that does not have a main method. It's utilized by other classes. So classes help contain and encapsulate groups of methods. That's what we're about to see. That's what you already see with the math class. Using the static keyword allows methods to be accessed from the class name from other classes, provided it's also public. So that's what public static means. And so it's just a better way to organize our code. Classes can contain both methods and variables. We saw that. with the math class because it had pi and it had all the methods we played around with. And then the final keyword makes a variable read only, or what we otherwise call a constant, and it prevents it from being changed. So again, just things I want to highlight since we looked at the math class. So we can invoke methods from other classes. This means that Java is an extensible language, which means that new functionality can constantly be added to it. That is, in fact, why we have a Java 18. Can anyone think of like the equivalent of a programming language where you can't add to it something that is not an extensible language? I could think of a couple. Using a calculator is like that, right? There's a closed set of instructions. You can only do so many computations with a calculator. A year from now, it's going to be the same set of computations on your calculator. Other examples, which might be a little bit out of date now, but like a microwave, for instance. I don't think that's out of date. Everyone still uses a microwave, right? It has some pre-programmed functionality that you can't expand, you can't extend. I mean, unless they have smart microwaves now, they might have smart microwaves now. Usually when something has the term smart, it means that it's now extensible. It can actually grow and evolve over time. DVRs are another example of that. Formerly old school VCRs, right, are programmatical, that you can program them, but it's a closed set of instructions that never extend over time. So that's what you can parallelize it with. That's what you can compare to when I say that our code is extensible. That's why Java is on version 18. Each version releases new methods, but you don't even have to depend on the architects to include new methods. You can include new methods the same way we did the math class. And I'm about to show you how we can do that, how you can create your own methods to use on your code base, because that's where it really shines, where we don't become reliant on someone else to give us the methods to share. We can start doing it ourselves, and we can create a shared collaboration of code that we each write one part of it once, and we all make use of it. We strive to classify similar sets of methods into a singular class. So remember, there's that metaphor that collections of related methods go into a single class. All math methods go in the math class. Yep. Okay. So let's take a look at making our own methods. We're going to create a maxgetter method. Let's go ahead and effectively the entire point of this method, because again, whenever we create the entire point of this class, because whenever we create a new class, we want to identify what is its purpose in our software application. This is just a proof of concept of we will implement a method that we've already come across inside the math class to see how maybe they implemented it. So we're going to do that work ourselves. So let's go into here, wait, where did it's probably behind. Oh, I see it. I got away from my computer. There we go. Okay, let's open up this. Okay, I'm going to update this here. I'm going to make this what it was before, so it's consistent with what's inside the slides. Okay, so in the maxgetter method, let's go ahead and start from scratch. So I'm going to cut out the implementation that's in the slide. So the first thing I would do is I would define a class. I want this class to be public because I'm going to use it inside of my math methods class. So this is we're going to build our own utility class, a class that is designed to support another class. This will be the first utility class that we've designed ourselves, because up to this point, every class we've created has always had a main method, which meant that it was an application class, right? It was a class designed to be executed. Okay, so that means I will not add a main method. Utility classes, you don't need to have a main method inside of a class. You only have a main method if it's supposed to execute and do something. The maxgetter class is not supposed to execute and do anything on its own. It's supposed to have methods that other classes will rely on. So it's going to start having code that it shares with some other class. so we can start breaking the logic down across meaningful ways. We'll see how that works in practice soon. Okay, so I want to show you two different ways that we can add code, and it's similar to what we already saw. Here, I can either add fields. A field is just another word that we can call a variable. I'm going to call this public static. Now, I'm not going to apply the final keyword because I want to show you that if I don't apply the final keyword, other classes have the ability to mutate this, which is really dangerous. We don't really ever want other classes to impose their will into our own class without permission, right? That's usually why we label our fields as private. But if I don't do that, you'll see how the math methods class will be able to access the pi variable, even though it's, another rule of thumb is when something's declared as a constant or read-only variable, you always use uppercase letters to illustrate that. So it's a readability thing. So you could read one line of code and identify whether something's supposed to be a variable you can write into, or it's a constant or a read-only variable, something that you can read the value of, but you can't overwrite. So we're going to pretend like this is a constant value. We're going to forget to put the final keyword, and we're going to accidentally mutate it inside of our code base. Then we're going to fix it. Then what I'm going to do in here is, let's talk about how we might implement max. In fact, why don't we make a better version of the max method than what's inside of there? In fact, I'm going to delete the code, and I'm going to see if we can't figure out how to implement this ourselves. Okay, so suppose we want to go ahead and figure out how to get the max value of 3 numbers instead of just 2, right? The math class is the trivial implementation. It makes a selection between A and B. What if we made a selection between A, B, and C? Okay, so that's how our max getter is going to work. So how might we do that? Why don't we now, since we're implementing the method, we now have to think about the nitty-gritty implementation details, right? Now we're in the role of designing the functionality of this method. So how do we do this? How do you do this in real life? If I wanted to decide which one is higher, is it A, B, or C? How do you mentally do that? Oh, let me give you an example. Which is higher, 2, 3, or 4? Okay, which is higher, 4, 3, or 2? Okay, which is higher, 3, 4, or 2? So everyone can do this, right? Clearly. Now, explain to me how we can tell the computer how to do that. Yeah, that's because that's what we do mentally, right? We evaluate the first number. So why don't we do this? What is it? So let's say we assume the first number is max. So we're going to create a local variable that represents our current max value. Max is going to be the first number because that's all we know about so far. Okay, what's the next thing we might do? And compare it, right? So if B is, and so what are we comparing? What should we compare it to? Yeah, it makes sense to compare it to A, but I'm going to argue for readability's sake, wouldn't it be better to use the variable max that we created? That'd be more readable, right? So if B, and so what's the relation between B and max for this if statement? What are we doing in here? So we know we're comparing these two. How should we compare them? Okay, so if B is greater than max, then what do we do inside that if statement? Then max is assigned the value of B. Okay. Perfect. Okay, so everyone's happy with that so far? Okay, so, but that's only part of the story. What do we do next? Yep, if, and now you see the strength of using the max variable as opposed to explicitly doing A and B, right? Because let's think about this. If we do max and we do the same thing, let's think about this. If B was greater than max, then max is the value of B. But if B wasn't greater than max, then max is the value of A. But it doesn't matter if it's the value of A or B, because at this point, it's still going to be the max value. Then, so we'll take whatever the current max is, we'll compare it to C. And if C is greater than max, then we will say that max is now assigned C. And now we're claiming to do what here in this part? We're returning a double. So what are we going to return at the end of this? We have to have a return statement, right? Anytime it's a non-void return type, that means it's a method function. So what's the end thing that we're going to deliver at? Max. Exactly. Okay, let's test this out. Now let's go into our, and let's compare this. Let's copy this and let's do, instead of max now what I can do is I can type in max getter, my own class. Since it's a static, since we define that as a static method, it's available from the class level, from the class name itself. And since it's in the same package, the package is the same folder, then it also gets implicitly imported. So we don't have to manually import it. So that's another rule you should know about. So in Java, the Java.lang package and any class files that share the same folder, the same package as the current class. So I can automatically use that and it will see that. And so here I'll do, what is the max between X, Y, Z? What should that result be? It's going to be 100.6. Okay, perfect. And also, let's do this. I'm going to copy pasta here. Instead of math.py, we're going to do maxgetter.py. And I just want to illustrate that we can define both fields that are available from our own user-defined class or methods. Let's test this out, and then I'm going to show you what happens by not making that read-only. Let's run that code really quick. And here, notice this is the max here from our maxgetter class, and this is the max from our math class. So notice we've replicated exactly the behavior that was given to us from the max class. That's all they're doing in Java. We just didn't have to think about how to implement it. But moving forward, we can start breaking our code base across various classes, and that makes it way more readable. It makes it much more easy to find where your methods are and where your code is inside of a larger code base. So when you start building out a larger application, it becomes much easier to debug it and maintain it and add to it. And same thing with this pi, it looks exactly, well, pretty similar. We didn't go as many digits, but look at this. Look what I'm going to do the pre-increment so that you could actually see the result. Because it's not final, I'm going to try incrementing pi. I'm going to, from the math methods class, tell the max getter class to increment its variable. And since it is mutatable, since it is writable, since it is mutable, we will be able to now say that now pi can be 4.1451590. So if I want to prevent that, all I have to do is add the keyword final in there. And so now if I try to go in, it's going to say, hey, you did an error here. You cannot assign a value to a final variable because it's read only. You're not allowed to write into it. So keep that in mind. If you're sharing data between classes and it's public, most often you don't want the other class to have permissions to override it because that's super dangerous. Because now any other computation that relies on the value of pi would now be wrong. So you want to have that accessible so other classes can read it, but you don't want them to also be able to override it. And so that's what the final keyword allows us to do. It allows us to share data in memory in a very approachable way. So the idea here is I could have expressed pi as 3.15149, right? But isn't it more understandable when it's in the math class and it has the name pi? That's what's called self-documenting code. We want to avoid what are called magic numbers in our code base. Magic numbers are code that is part of your logic that affects something, but it's not giving context. It's not given context because it just appears as a number. Remember, we're in the business of mathematical modeling. So we should ascribe context to all the numbers we use. So if you make a decision based off of a number and that number doesn't change, don't just use the number, create a constant value that has a meaningful word and make it final and use that for your logic, because that gives other authors, even yourself in the future, your future self, the context to understand why you're comparing against that number. We're going to look at that in the next lecture. I'll give you a demo of that. Is there any questions? I ran out of time. Is there any questions? Okay. How are you guys feeling about methods so far? Excellent. Okay. Oh, yeah. That should be right here. Excellent. Okay. So if there's no questions, we'll pick up with methods again on the next lecture, which I will pre-record and share with you all. I'll send an email out when it goes live, and I'll just expect that everyone kind of watches that from whenever I post it. So I will see you all in person on next Thursday. It's gonna be for my brother's birthday. So
The older or younger?
younger.